And the next question is about directly from gases, theoretical part. So calculation related. Okay, I have to move fast now. So, okay. So you have given a mixture of O2 gas. So I will draw it. So we have O2 gas and O3 gas mixture. And you have pressure P and temperature T. And in fact, they have given the volume as well. Okay. So they have asked to express the density in terms of N1, N2, M1, M1, M2, and V, where in the definitions are given. N1 is the number of moles, M is the molar mass of it. So the general equation for density is mass over volume, right? So volume is given, that is V. So in the fraction, you need to have V. On top, we have to have mass of oxygen plus mass of O3 because we have these two. But how to get the mass of these two? They have given for oxygen it is N1 and the molar mass is M1. Okay, as I think. Yes. Yeah. So O3 it is N2, it is M2 because you know number of moles is equal to mass over molar mass. So mass is equal to N into molar mass. Okay, N into M. So you have to do what you have to do is you have to just plug this N1 M1 plus N2 M2 over V. So this is the density of this solution. But sometimes people forget to understand for a solution, remember, density is given for the entire solution or entire mixture, which means you need to take total mass. Okay. In a gaseous mixture or in a solution, remember, here both are gases. So sometimes you might think, okay, density. So can I describe the density here for oxygen separately and ozone separately? That can be a question that can come to your mind. Like taking the mass of oxygen separately and divide it by the volume. Taking the mass of O3 separately and divide it by the volume. Then you have the density for oxygen and density for O3. Can you do that? What do you think about that? Think about that. Because in solution, when you describe concentration, you can separately write down a concentration for oxygen and a concentration for O3 because its number of moles are different. So concentration is number of moles divided by the volume. Okay. But remember, concentration you need to specify for each of these two. But density, based on its definition, it is described for the mixture, not for each individual species. So you cannot separately write down density of oxygen, density of O3 when you have this mixture. Okay, this is a mixture. So the first part is done. Okay, so someone is waiting. Let's see. Who is this FL Pro Gaming? Okay, we will see. The next question is express the above relationship in terms of x1, x2, m1, m2, v, and n. So we have the solution for density that was n1, m1 plus n2, m2 over v. And now what they are asking here, is to express this relationship in terms of x1 and x2, which means here, remember, what you have to know here is, and for this first question, we have this expression. For the second one, additionally, they are telling us to use x1, x2, and m1, m2, and n, which is the total moles. Okay. When you see this x1, automatically it should come into mind. They are now talking about mole fraction. So what is mole fraction? So the mole fraction is number of moles over total number of moles. So if you want to mention the mole fraction of O2, I think it will be x1. It should be equal to number of moles of O2 over total number of moles, which is n. Here it is given. So if you know the number of moles here, you can plug this to here, n1. That is the idea. So when you want to put O2 number of moles, it will be equal to NO2 will be equal to, wait for a while. Okay, so NO2 will be equal to N into X1. So in the same way, you can predict NO3 will be equal to N into X2. Okay, finally you can put these two here and here, and for the density, now you will have an equation like N into X1 M1 plus N into X2 M2 over V. Or either you can rearrange this as x1 m1 plus x2 m2 times n over v. Okay, so you can have this final equation. So this is very straightforward question. Okay. Okay, now the last part of this question, that is hence show that you have to now show x1 is equal to 3 minus dRT over 16p. You have to show this one. Okay, but what is the equation that we have now? That is the idea. So the equation that we have for density here is we have x1 m1 plus x2 m2, okay, times n over v. So this was the equation that we had in the previous question. Okay, now how can I combine this with this one? Because the idea here is I want to remove. Now, if I want to get x1, first thing I have to remove x2 in terms of x1. That can be done because I know x1 plus x2 should be equal to 1. So in terms of x2, I can write down 1 minus x1. And I can put this one here. That is 1. Okay. And you see I have RT and P. So this should give the idea to you. Here they have used PV is equal to nRT to get the idea of this reaction mixture. In fact, there is no reaction, in fact, in this mixture. So if I use PV is equal to nRT, okay, I can see there is a ratio here, N over V. So if I get that ratio here, same, N over V, it will be equal to P over RT. Okay. So N over V is equal to P over RT. So shall I put this here? It will be P over RT. Okay. And if I rearrange, I can take this here. So dRT over P. So that is the factor that I see here. dRT over P. Okay. So dRT over P will be equal to x1 m1 plus x2 n2. I have this equation. The final equation is this. Now I told you I can substitute this here. And at the same time, now I need to replace this m1 and m2. How can I do that? That's my next idea. Okay. So how to do this? Very simple, because you know x1 is for oxygen. So you know the molecular weight of oxygen is 32. And m2 is for ozone. The molecular weight of ozone is 16 times 3. That is 48. Okay. And here x2, you can write down 1 minus x1. So I have an equation, dRT over P is equal to 32x1 plus 1 minus x1 times 48. So in fact, dRT over P is equal to 32x1 plus 48 minus 48x1. Right? So the easiest way is to, here there is a difference of 16x1. So 16x1 you can take to the other side because this is minus 32x1 minus 48x1 is minus 16x1. So you can take that to this side and you can take this to this side. And it will be equal to 48 minus dRT over P. Okay. Then you can divide this by 16. So x1 will be equal to, if you divide 48 by 16, it will be 3 minus, there is dRT over P. And you divided this by 16. So there will be a coefficient here, 16. This is the final answer that you need to show. Okay. So you get the idea. The idea here is to use the ideal gas equation, PV is equal to nRT, and you have to rearrange the equation that we used in question number 2 and get a factor for N over V, that was dRT over P. Then use the molecular weight of oxygen and ozone to get this relationship. That's all. Okay. The only difference is you need to replace N over V and M1, capital M1 and M2, which are the molecular weights. Okay. So the next question is, state the assumptions that you made in the above steps. Okay. So above steps means what are the assumptions? If you can remember, in the previous question, we used PV is equal to nRT. The first point is you need to mention O2 and O3. Those are behaving as ideal gases. So the mixture behaves ideal. That is one thing. And the second thing that you can mention here is there is no reaction between ozone and oxygen, molecular oxygen. There is no reaction between O2 and O3. That is another assumption that you can write. Okay. Okay, so that is done. That part is done of question number 3. So we will go to question number 3, part B. So here you have given a set of reduction potentials for Br2 becoming Br minus, it is 1.07 volts. Okay. I minus, I2 to I minus, it is given 0.54 volts. So these are reduction potentials. and they are asking about what type of reaction that you can expect when liquid bromine is added to Ki. So first thing that you need to understand here, you need to find which one is likely to get oxidized and which one is likely to get reduced. Okay, so we have Br2 liquid to Br minus aqueous. It is given as 1.07 volt, and I2 to I2 to I minus 0.54 volts. Okay, so if you can remember about our electrochemical series, I told you the elements on top, they are highly likely to be in the oxidized form, where its reduction potential is very low. Very low means it can be negative or a positive value which is lower. So based on these two, which one is lower? 0.54 is lower than 1.07. So more or less, when you think about iodine, it is more likely to be in I2 form, because this is the oxidized form of I minus oxidized to I2. And Br2, it is more likely to be in the Br minus state. Why? Because that is the reduction state. Okay. So what is the reaction? So in principle, you can write down Br2 gets reduced to 2Br minus aqueous. Remember, when you do physical chemistry questions, always you need to put physical states of the reactants or the products, and always need to put units as necessary. Every time you write down something, you need to write down physical states and units where it is necessary. Okay, always you can put. So Br2 is reduced to Br minus. So there is 2 electrons released, and at the same time I minus is oxidized to I2. So I am balancing the mass, then electrons. So the reaction that normally happens here is Br2 liquid, I minus Aq to I2. You can either write down I2 solid, or you can think about I2 solid forming and again reacting with excess I minus to form I3 minus aqueous. Okay, but you don't need to write down that two. You can write down this one. So you can write down Br2 liquid plus 2I minus aqueous, giving 2Br minus aqueous plus I2 solid. So this reaction can be right. Okay, this is the reduction, this is the oxidation. So what color changes you expect in the Bohr experiment? So Br2 and I minus, what is the color? I minus does not have any color, it is colorless. And Br2 in general, it can have like a pale yellow color. So these two are the reactants here. So it can be pale yellow. Okay, at the end Br minus, no color, but there is I2 that is formed. Okay, so what do you think about the color that it will form at the end of the reaction? Okay, remember you have I2 solid. Remember I2 solid in air, it is I2 forming the solid, it evaporates very quickly and it is purple in color. Okay, but here the I2 is formed in solution. Okay, so when you have this reaction, you can see Br2 and I minus is converted to I2 solid and Br minus. But I2 solid, remember, there is excess I minus in the solution. So it will be always in I3 minus form, which is brown in color. Okay, so remember about that. But for this particular question, it is enough writing this. Okay, if you want, you can write down I minus giving I3 minus, because within I3 minus you have I2 plus I minus in equilibrium. and this equilibrium is more or less shifted towards the right hand direction. Okay, remember about that. Try to remember about that. But for the reaction, this one is enough. Okay. Okay. Part 2. Consider the following electrochemical reaction. So again, you have given an electrochemical reaction that is, yeah, I will just share screen at this time. Where is it? Yes. Okay, so we are here. We did this one. So the second part is consider the following electrochemical reaction. So here you have given a electrochemical reaction where magnesium is oxidized. You can see magnesium solid forms magnesium 2 plus, and H plus is reduced to H2 gas. So write the cathodic reaction of the galvanic cell consisting with the above reaction. So what is the cathodic reaction? 2H plus 2 electrons gives H2 gas. Okay. Write the conventional notation for representing above cell, which includes a salt bridge. Okay. So I think I have to use the board here again. Okay. So the idea is this. So we have given a reaction. That is the important thing. Okay. So we have given a reaction. Magnesium solid will be oxidized to magnesium 2 plus aqueous plus 2 electrons. That is this. The reduction is 2H plus AQ plus 2 electrons will form H2 gas. So when you think about the cell, if you have a bulb like this, and this is one electrode, and this is another electrode. So one will be the oxidized one. So this will be magnesium solid and magnesium 2 plus. And we'll say concentration is 1 mol Dm minus 3 for an example. And here the other one is hydrogen electrode. So there will be hydrogen gas pumping at 1 atm pressure, 25 degrees Celsius both. And there will be platinum wire here coated with hydrogen, and there will be a H plus aqueous solution. So this is the cell, and now we have a salt bridge like this. Okay, we have a salt bridge like this. So here there will be the anodic reaction, and here there will be the cathodic reaction. So the anodic reaction is this, cathodic reaction is this. Now they are telling to show this as a notation. Okay, remember this is the cell. You have the anode, then you have the salt bridge, and you have the cathode. So the cell notation is also written down in the same way. Okay, do I have any questions? It says the color changes from colorless to brown. So which species is colorless? The color of Br2 was initially present, right? Yeah. So basically, you can the colorless is I minus, but pale yellow color is also accepted because there is Br2. Okay. So don't forget that there is Br2. There is a pale yellow color. So pale yellow color, then it turns. Okay. So the idea is here in terms of cell. So if you can quickly think about how this cell can be present as a picture, it will be very easy for you to write down the cell notation. Because in the cell, you have the anode, then you have the salt bridge, then you have the cathode. So in the same way, here we write the anode, that is magnesium solid. Then we put a single line. Why this single line? To show the phase change. What is the phase change? Magnesium solid to magnesium 2 plus aqueous. So there is a phase change from solid to aqueous phase. So we now have explained the anode cell. Then in between we have the salt bridge. So I have to put two lines which indicates our salt bridge. So I have explained the anodic reaction as well, magnesium to magnesium 2 plus. That is the anode cell, anodic reaction. Then salt bridge. Now you have to go with the cathode. Okay. To write down the cathode, what do you have to do? Think about that. You start with hydrogen OH plus. That is the thing that you need to think. Because remember, anode reaction is from magnesium to magnesium 2 plus. So the cathode reaction will be H plus to H2 gas. So that is how you need to write. Okay. So someone is again joining. Yeah, join. So the idea is you need to write down the anodic reaction, then the salt bridge, then cathodic reaction. Okay. So what is the cathodic reaction now? It starts with H plus, right? So H plus aqueous. Then there is a phase change, that is H2 gas. And remember, when you write down gas electrodes, there is this platinum additionally that you need to add in the cell notation. So it will be platinum solid at the end. Okay, remember that. There is magnesium, magnesium 2 plus, anodic reaction. Then the salt bridge is this. Then the reduction, OH plus, H2 gas, platinum solid. So here there is also a phase change. So therefore I can put this dash here, slash. Or in some cases it is accepted. The comma is also accepted. But remember, this is the most suitable way. Okay. So this is the cell notation that you need to know. Okay. Okay. In a cell notation, isn't it compulsory to write anodic reaction first? Very necessary. That is why I told you. In the cell, you have to first explain the anodic reaction. So this is the anodic reaction. Magnesium, magnesium 2 plus, oxidation. You should write down always first this. Then secondly, you need to mention the cathode reaction. What is the cathode reaction? Reduction. So anodic reaction, salt bridge, cathodic reaction. That's it. That's the order. Anode, salt bridge, cathode. Anode, salt bridge, cathode. That's it. Okay. That is the process that we write here. Okay, remember. Here you can have these two reactions where one is oxidation, the other one is reduction. So for the oxidation, you need to write down the oxidized reaction, that is magnesium to magnesium 2 plus. In the reduction, you need to write down the reduction reaction, H plus to H2. Okay, please try to remember that. Okay. So the next question. So this is the cell notation. So the next question is, does the entropy increase or decrease or remain constant when the above cell reaction proceeds? So this is very important to understand. This is in fact not a question that is mostly related to theory, but it is also regarding the theory. You need to understand here. They're asking about the entropy. So easiest way to identify whether the entropy increases or decreases, because they have just asked about entropy increases or decreases. No reaction or reason. Yeah, the reason asked, briefly explain your answer. So here, when this reaction happens, you can see a solid reacting with an aqueous solution forms an aqueous solution and a gas. So here is the solid. It reacts with the aqueous solution and form an aqueous solution and a gas. So what do you think about the entropy? Entropy in general, we say it is the amount of disorderness in the solution. So here you can see there is a gaseous product that is formed. So when there is a gaseous product that is formed, the disorderness is very high, which in return it says that the entropy should be increased. Because for a solid, the packing arrangement is very smooth and solid and tightly packed. The entropy is poor because they cannot move as they want. But when you go from solid to liquid, there is a little space among the molecules, so there is a freeness. When you go from liquid to gas, there is a high random nature. The gas molecules will go everywhere. So the amount of the what you call the entropy is very high for a gas than a liquid, than a solid. Okay. So in this reaction, you can mention for the reason there is a gaseous product that is evolved, which causes the entropy to increase. Okay. So you have to first write down entropy increases. Then the reason is gaseous product H2 is formed from solid and liquid phases. Okay. What should be the relationship between enthalpy change and entropy change for the above reaction to be spontaneous? So this is very straightforward, because according to our enthalpy, entropy, and Gibbs free energy equations, so we have this equation, delta G is equal to delta H minus T delta S. So this reaction is spontaneous. Okay, automatically this reaction is spontaneous. Why? Because you know the reduction potential of this one and this one is comparable. It was 0.54 and 1.07. So you can even calculate E cell as well. And when you calculate E cell, it is a positive value. So if this is a positive value, which means this reaction, this cell reaction is spontaneous, which means it gives the idea where delta G should be negative. Okay, it is less than 0. So if this value is less than 0, what do you mean by this? It is like, let's say, minus 10, for an example, kilojoule per mole. So you can automatically think about this situation where your delta H minus T delta S greater than 0 or less than 0. That is the idea that you. This one or this one. You can use the chat box and tell me the relationship is this one or this one. This reaction to be positive, I mean spontaneous. Quickly use the less, yeah, so first or second. Okay. I have two answers, first and second. Right, so we will discuss that for a bit. Okay, now see. There is the correction. Sorry, second. The idea is now this reaction is spontaneous, right? So the delta G should be negative. It should be a negative value. So if this coefficient is positive, delta G is positive. So if this coefficient is negative, delta G is negative. That is the idea. So more or less, this coefficient is equal to delta G, which means this coefficient should be less than 0, which means it is a negative value. Okay. So you can write down in this way, or either you can explain it logically. Okay. But if you write down this straightforward answer, that is done. But if you want to logically explain that, it takes some time to write as well. Okay, so you can write down simply the inequality like this, and that is the answer. That should be the answer. Okay. Or in fact, you can rearrange this as well, right? For an example, the answer should be this. It should be less than 0. Then you can put this here and change the inequality mark and write. There is no point in write like that, but this is enough. What is it? Delta H minus T delta S should be lower than 0 because delta H minus T delta S is equal to the Gibbs free energy. So when if this reaction wants to be happening in a spontaneous way, delta G should be negative. Okay, so that makes the end of this question number 3. So it is a very nice question because first part is related to a calculation and second part is related to a more logical approach. Okay. So we will move on to question number 4, organic, very quickly. So this organic question was very small in fact, but there is a big fact that you need to take here. Okay. So we will discuss the organic question. If you have any question meanwhile based on question number 3, and you can ask me. Right, so question number 4 tells there are 3 isomers. Okay, I will write down like this: A, B, and C. With molecular formula, E cell positive means reaction is spontaneous. Yes. So I will come into that very briefly. Okay, very briefly. So we had the cell like this. Platinum. Let's say this is a bulb. So this was magnesium 2 plus aqueous solution. This is magnesium electrode. And its potential was given. Where was it? Yeah, potential is not given, but its reaction is given. This is oxidation. So we will say this is around minus 0.7 volt for an example. And platinum is 0 volt. With hydrogen, it is 0. So E cell is equal to E cathode minus E anode. Okay. So E cathode is this 0.00 volt minus E anode is magnesium, always like to be in magnesium 2 plus form, oxidizable. So more or less the voltage is negative. So minus 0.7 volt. So the E value is positive 0.70 volt. Okay. Now you have asked the question, E cell positive means the reaction is spontaneous. Yes. Yes, it is spontaneous. But at the same time, you can have a question, why? Why means E is equal to, remember, E cell naught plus NF over RT ln Q. And there is another equation that you need to remember, that is delta G is equal to minus RT ln K. So these two you don't need to remember. This is at university level. I am going to tell why this is spontaneous, because this reaction E cell becomes positive means, okay, this E cell becomes positive means this equilibrium constant is positive in this equation. And if this equilibrium constant is positive, this entire cofactor becomes negative. Therefore, delta G becomes negative, which means the reaction is spontaneous. Okay, but you don't need to remember these two equations, but at least try to remember this equation. Okay, this is ln K means natural log value ln, or either you can write on 2.303 log K. Try to remember this equation, please. And K means the equilibrium constant, where you have the salt bridge and you have the oxidation and reduction. In this reaction that is given, ln K On top of the fraction, you will have magnesium 2 plus concentration times H2 gas concentration over magnesium solid concentration, H plus aqueous concentration to the power 2. But magnesium is a solid, so we don't put that concentration here. Okay. You don't need to know much. Just remember this equation, because this equation is given in one of the following papers. If you can remember, in 2011 chemical kinetics question, I explained to you that the last part where they have used the equilibrium constants of the subsequent mechanistic steps to derive a final equation for the rate. I told you this is not related to your syllabus. In the same way, this equation is not related to your syllabus, but they can give this, they have given this to predict the delta G by using the equilibrium constant. Remember, because they have given a reaction and they have tried to ask you to calculate the equilibrium constant, and now they have given this equation and they have told you to predict whether this reaction is spontaneous or not. So you have to use the equilibrium constant here, and they have given the temperature, then you know R, then you can calculate delta G. So if you know the delta G value, if it is negative, the reaction is spontaneous. But for a cell reaction where the E cell is always positive, it is spontaneous. Why? Because of this. So I cannot go further and further about this.